Okay, so if you watch section 2.1, it was factoring straightforward polynomials. Now we're factoring quadratics with an a term that cannot be factored out. Okay, now there's multiple methods of doing this. There's three that I'm comfortable with. There's another intuitive method, and you know what? There's probably more. I'm going to focus on this one. I'm going to go out on a limb and say most of you will probably have looked at this one in grade 10 if you saw it. So I will do my best to show both in the later examples. But I really like this one. So we call it the AC method because look, A, C. So if you have a quadratic like this, where you can't factor out the leading term, you take that 6 and you multiply it with the 2, and you rewrite the polynomial like this. So you rewrite it now with the 6 times 2. Then you factor that as you normally would, and you'll see we end up with x plus 3 and x plus 4. But that's not your answer. That's not your answer because that's the answer to this and not the answer to this. So you need to say, okay, well, what did I do to this thing here? You multiplied the c term by 6. And if you remember our polynomial breakdown, this term and this term multiply together to give you the c term. So to get the accurate c term from our actual polynomial, you divide both of them by whatever you multiplied the c by. So in this case, 6. Simplify your fractions. You have to simplify your fractions after that. And here you end up with x plus a half and x plus 2/3. Now, I'm just going to show you this, but I'll explain it in a minute. You then take this and you write it up there, and you take this and you write it up there. Now, why do you do that? So you end up with this. And you can check that using FOIL, and that's how you always double check. 6x squared, 2x, 3x, 4x and 3x is 7x, good. 1 times 2 is 2. So you know you did it right. So always check to make sure you did it right after. But why do you do this weird write the 2 up and write the 3 up? And it's actually less complicated than you'd think. It's because when you start actually solving these, and you'll see we're going to do that in section 4, they're equal to 0. Okay, and if we're looking at this, it's basically, I just don't like dealing, so you'd have this. I just don't like dealing with fractions. So if I multiply this side by 2, and I multiply this side by 2. Well, this 2 is going to multiply into here and into here. But it's not going to get a chance to multiply into the next one, right? Because it's 2 times this times this. You don't multiply it into both. You multiply it into one of them. So I'm going to do that. And what happens? Well, you get 2x plus 1. And then times x plus 2 over 3 equals 0 still. It's like, okay, what if I multiply this side now by 3? And instead of multiplying the 3 into the first one, I'm going to multiply it into this one. Now, if that confuses you, I just want you to picture this. 2 times 3 times 4. I could do 2 times 3, and I would have 6 times 4. So I didn't touch that, just like I didn't touch that. Or I could do 2 times 4 first, which is what I'm doing on the second one. It's totally allowed. Multiply this by 3 also. And now the 3 times x is 3x, and then the 3's cancel, so plus 2. So you see we end up with this, and this is still 0. So that's why you do that, but just the shorthand's there. Now, if you like factor by grouping, I'm going to show you factor by grouping down here. For me personally, generally for students at this level, you're more confused by it. I know a C method can be a little confusing, so I mean, we're talking confusion and confusion, so hey, might as well show you both. Factor by grouping. Now, if you look at factor by grouping, our original polynomial was 6x squared plus 7x plus 2. And what you're doing is you're looking to break the 7x down into factorable components for the 6 and the 2. So to me, that already sounds confusing. But I'm going to say this. I'm going to say, okay, well, 6x squared plus 3x plus 4x plus 2. And if you look, this is still 7. Right? Good. So now you look at that and you're like, okay, well, this first half, just this half, I can factor out a 3x. And I'll be left with 2x plus 1. And then this back half, I can factor out a 2. And I'm left with 2x plus 1. And now you have this and this, which is a common factor. So you can factor it out, and you have 2x plus 1 times 3x plus 2. So you get the same answer, and it works. Now, some people might be like, well, that's way easier. And you know what? It might be. But let's just look here. What happens if you break the 7x into, plus 6x plus x plus 2? Well, now you're looking at this, and you're like, well, I can factor out a 6x, and I'm left with x plus 1, and then I factor out a 1, and I'm left with x plus 2. It's like, oh, well, that just didn't help me because these aren't the same. So you have to be careful to what you split that into. So that's the only hurdle. See, I knew to split it into 3 and 4 because I knew I'd end up where I wanted to be. So again, these take practice. AC method's nice. Factor by grouping I enjoy. But here's another example. I'm just going to let you look through this of the AC method. So A times C changes to this. Factor it, divide by A, simplify your fractions, and then if you can't, you bring that up to the front. Check using FOIL. Here's another example. I'll just let you read through it at your own time. These are all done in AC method. Now, when you're doing practice, I say use grouping or AC, totally up to you. What I'll do actually is let's go back one page, and we'll do this one using factor by grouping, just so I can show you why, for me personally, it can be a little bit more confusing depending on the numbers given. So you have this. So you're looking like, because now the question is, what do I break that 5 into here? You know, like you have a negative 5, and you have a negative 24 and a 12. So this takes a little bit of thought process, a little bit of ingenuity almost, right? Because you don't know the answer. You know that this could be either a 12 and a 1 or a 3 and a 4. And what I mean by that is here's a 3 and a 4, or those could be 12 and 1, right? Like we don't know. So how do you even start? You could say, well, negative 5. How could I represent negative 5? Well, I could represent negative 5 as, how about negative 8x and positive 3x minus 24. Let's see if that works, right? Because this is still negative 5, right? This is negative 5. Well, the first half I can factor out 4x. And I'm left with 3x minus 2. And then I can factor out a 3x. And I'm left with, just a 3, x minus 8. Yeah, see? So it didn't do it. So you need to keep working until you find it. That is why I think the AC method for me is more straightforward. Now there's one other intuitive method that can be pretty clear depending on the example you have. But if you have something like 12, what I mean by intuitive is and I kind of alluded to it a second ago, you got a few possibilities. You can have a 2x and a 6x. You could have an x and a 12x. Or you could have a 3x and a 4x, right? Because all of those leading terms multiply to this. Now, if you look at your back term, you're looking for negative 24. So you're looking for two numbers that multiply to negative 24. But then you need to find two numbers that add to negative 5, including that. So again, this is quite involved. It's like, well, how do I decide what to put here? I could put a minus 12 and a plus 2. It's like, yeah, but how do you know? Because now it's 2 times 2 is 4x, and that's, 72x, not going to work out. So again, both of those methods are more challenging, require a higher level of intuition, so stick with the AC method when in doubt. It won't lead you astray. It's the same process over and over. You got lots of practice here, so please practice, practice, practice. Remember questions like this, write in descending order first. Questions like this. Oh, questions like that. You know what? I'll do one of those for you. These are higher level thinking questions. This is where you can use you don't even have to, but you can use a mathematical beauty here by saying, let x squared equal x. And right now you're like, what the hell does that mean? That means x is x squared. So you could rewrite this as, because x to the power of 4 is x squared squared. So now what you have is you have 8x squared, because this we'll just write as x. Or you know what? For the sake of it, I'll just change the letter so it makes your life a little bit more, you're not looking at the same thing, but it's the same concept. We'll just say let x squared equal y. So now you have x squared squared plus 19x squared minus 27. So then anywhere you see an x squared, you can replace the letter y. So now you have 8y squared plus 19y minus 27. So I've subbed y for that, and I've subbed y for that. And now you solve this AC method, y squared plus 19y, 8 times 27 is 160 plus 56. 160 plus 56 is negative 216. So now I'm looking for two numbers that multiply to 216 and add to 19. So it's like, well, okay. 216 is... So these, I'm just starting to factor this down, right? 27 and 8, boom. So 3 times 9 is 27, and then times 8 is 216. And this is 19. And what's 27 minus 8? 19. So you have y plus 27, y minus 8. Now I may make this look easy, but it's because I've been doing it for a while. Now what was my a term? My a term was 8. So divide by 8, divide by 8. You get, can't simplify, so you get 8y plus 27, and you get y minus 1. Now the thing here is you're not, now you could double check this, right? You're going to have 8y squared minus 8y plus 27y is 19y, then minus 27. So I actually do get back to this. But the problem is that y was equal to x squared. So you're going to sub that back in. Get that, and you get that. Now why did I do that? Well, because you can still, this, nothing I can do. But this is a difference of squares. So I can actually break it down even further. And that is the full answer. Those are hard, but that's why they're at the end, okay? Have fun, practice, and I'll see you next section.